बच्चों, let us see this question. Which of the following complex compound is paramagnetic? Which of the following complex compound is paramagnetic? There are four options A, B, C, D. We need to select one correct option after solving. हमें ये चारों ऑप्शन में से जो पैरामैग्नेटिक कॉम्प्लेक्स है वो बताना है. चलो लेट अस सॉल्व दिस वन बाय वन. फर्स्ट कॉम्प्लेक्स देखेंगे, निकेल का कॉम्प्लेक्स, निकेल DMG complex. DMG means dimethyl glyoximate ligand. Okay, it is a bidentate ligand. As bidentate ligands are two, and the name also starts with di, this complex name is bis dimethyl nickel 2 complex. Okay, and its structure will be like this: double bond N O minus, single bond C, double bond N O minus with a CH. Okay, I wrote this is a trans form. Cis form also existed. Okay, but cis form forms chelates, which are giving a stability to the complex. Now I'll write cis form. Observe this. Just I'm changing the double bond position here. So then I'll get cis form. Here CH3, same groups on same side, CH3, CH3. And we can write here double bond NO minus. So this is cis form of DMG ligand. Now it is forming chelates with nickel. What is nickel here? Nickel atomic number is 28. Its electronic configuration argon 4s2 3d8. In this complex, nickel is in the +2 oxidation state because dimethyl is -2 here. See, this is one negative charge and this is another negative charge. So nickel oxidation state, how can we calculate? Nickel oxidation state X plus 2 into -1 is equal to 0. X is equal to +2. So nickel oxidation state is +2. So it lost 2 electrons and it has 3d8 electronic configuration. 3d8, 8 electrons arranged like this: 1, 2, 3, 4, 5 and 6, 7, 8. Now, as this is a strong ligand, pairing takes place again as the Hund's rule. So, this outermost p orbitals are also available. For p also available, for d orbitals also available. But how many coordinate covalent bonds it is forming? It is forming two coordinate with this one coordinate covalent bond, with this oxygen one coordinate. So each one forming two coordinate covalent bonds. So 2 2s are 4 coordinate covalent bonds required. So 4 orbitals required for this. See, this electron is jumped. This is 3d, 4s, 4p, 4d. Now electronic arrangement. After pairing 1, 2, 3 already pairs are there. Fourth pair this is. So d orbital is vacant. This d orbital and one s orbital and two p orbitals involved in dsp2 hybridization and forming square planar complex. So tell me, is there any unpaired electron here? There is no unpaired electron. As there is no unpaired electron, it is diamagnetic. So it is a diamagnetic complex but not paramagnetic. Question में क्या पूछा है? Paramagnetic complex बताना है, but this is a diamagnetic complex. Now go to the B option. In B option, what is given? FeH2O5NOSO4. Actually, this is a brown ring formula. And here this NO oxidation state is +1. Now let us find iron oxidation state here to get the structure of the complex. Iron oxidation is taken as X oxidation state, and H2O is a neutral ligand. So oxidation state of H2O total molecule is 0 plus 1 into NO is +1 and sulfate is -2. So is equal to 0. X plus 1 minus 2 is equal to 0. X minus 1 is equal to 0. X is equal to +1. So here iron is in +1 oxidation state. You know that iron atomic number, that is Z is equal to 26. Iron electronic configuration is argon 4s2 3d6. So it lost how many electrons in the to form complex? 1 electron. So to form Fe plus. So iron lost 1 electron. So its configuration becomes argon 4s1 3d6. The orbital picturization 3d 4s 4p and 4d. So 4p orbitals available, 4d also available, but no electrons. Now 3d6 electronic arrangement 1, 2, 3, 4, 5 and 6 and 4s1. As NO is a strong ligand, pairing takes place. Therefore, this s electron is jumping from here to here and pairing starts. So here this d orbital, observe this is 1, 2, 3 pairs of electrons are there, and this is 1 and this is 1. Remaining s orbital vacant, p orbitals vacant, and outermost d orbitals also vacant. Now, you may have doubt that why this is not pairing with this electron. If this is pairing with this, we get only one d orbital vacant. So actually to form a inner orbital complex, two d orbitals are required for this, because here in this complex coordination number is equal to 6. So ligands also approaching 6. So it has to arrange 6 orbitals. So here, even though if it is paired up, we get only one d orbital vacant after pairing also. Therefore, so there is no need of pairing up of electrons here, because there is no use even if it is paired up, only one d orbital left. So that is not participating in the hybridization. We require two d orbitals. They are not available in case of 3d. So therefore, it uses outermost orbitals for hybridization. One s orbital, 3 p orbital, and 2 d orbitals of the outermost shell involved in the hybridization sp3d2 hybridization. So that's why it is a outer orbital complex. And here unpaired electrons are available. See this one. How many unpaired electrons are there? Two unpaired electrons are there. As it is having two unpaired electrons, two, even if one electron also if it is there, it is paramagnetic. So due to the presence of unpaired electrons, it is paramagnetic. Question में क्या पूछा है? Which of the following is paramagnetic? So this is paramagnetic. Why? Because of presence of unpaired electrons. Option B is the correct answer. Now let us see the option C. Option C में दिया है Na2FeCN5NO. The central atom is iron. Let us find iron oxidation state here. So 2 sodium, so 2 into +1, and iron oxidation state we are going to find, that is X, plus 5 into Cn minus, right? -1 is the oxidation state. So NO is the neutral ligand here. Here NO is a nitrosonium ion, so means NO is a +1 oxidation state. So 1 into +1 is equal to 0. 2 plus X minus 5 plus 1 is equal to 0. X minus 2 is equal to 0. X is equal to +2. So iron oxidation state is +2. Here iron atomic number is 26. Its electronic configuration is argon 4s2 3d6. This is a atomic electronic configuration of iron atom. But iron lost how many electrons? 2 electrons. So iron lost 2 electrons from the outermost shell and becomes Fe plus 2. So its electronic configuration is argon 4 3d6 and 4s0. 4p orbital also there 0. 4d orbitals also there 0. So we see the electronic picturization of this d orbitals having 6 electrons and s, p orbital and outermost d orbitals also. This is 3D, 4s, 4p, 4d. So pairing the electrons arranged like this. 1, 2, 3, 4, 5 and 6. Now as the NO is a strong ligand, Cn minus also strong ligand, what will happen? Pairing takes place again as the Ohm's rule. So in the next picturization of electronic configuration, pairing of this electron is paired with this and this is paired with this. So 1, 2, 3 pairs of electrons. D orbitals are available here. So these d orbitals now involved in the hybridization, D2sp3 hybridization, because here in the complex the coordination number is 6. 6 monodentate ligands are there. So it needs T6 orbitals. So it undergoes inner d orbitals are as it is available. It undergoes D2sp3 hybridization, inner orbital complex. So is there any unpaired electron? No unpaired electron. Even after the bonding with ligands, no unpaired electron. So hence it is diamagnetic. Question में क्या पूछा है? Which of the following is paramagnetic पूछा है. So ये paramagnetic नहीं है. Option C is not the answer for this question. Now अब fourth option देखेंगे. In fourth option what is given? CONH3 6 plus 3 CONH3 6 plus 3 complex. So let us find the oxidation state of cobalt. Cobalt is X plus 6 into ammonia is a neutral molecule equal to the charge present on this. So X is equal to plus 3 means cobalt oxidation state is plus 3. Now here cobalt atomic number is 27. Its configuration is argon 4s2 3d7. So it lost how many electrons? 3 electrons. So outer from outermost shell. 2 electrons from this and 1 electron from this. So now it has a cobalt plus 3 electronic configuration is argon 3d6 4s0 4p0 4d0. Orbitals are available but no electrons. So this d orbital, inner d orbital 3d 4s 4p, the electronic arrangement is 1 2 3 4 5 6. This is 3d6 electronic arrangement. As here pairing takes place like this and this is also pairing like this. So there is no unpaired electron. 1, 2 and there is no unpaired electron. Inner d orbitals are available. Hence it undergoes D2sp3 hybridization. So D2sp3 hybridization. No unpaired electrons. There is no unpaired electron, hence it is diamagnetic in nature. So this option is also wrong, but because हमें paramagnetic nature कौन सा है बताना है. So ये C, D options are diamagnetic and B option is paramagnetic. Okay. So option B is the correct answer for this question. Option A wrong, option C wrong and option D also wrong. Option B is the correct answer for this question. Hope you understood. Good luck.